In the previous video, we talked about binomial theorem and we looked at how we can use the theorem to do binomial expansion. Well, let us first do a quick recap of binomial theorem. Recall that binomial theorem says that if we have two terms and we have the sum of two terms and we want to raise these two terms to the power of n, then we can expand it as a sum of terms that are made out of three components. And all the terms, they have something in common, which is n, a, b, n, a, b, n, a, b, and n, a, b. What differs from one term to the next is the number below. So it starts from 0, 1, 2, 3, 4, 5, and so on until we end at n. And then the powers for a and b, this is the same as this number. So the two numbers at the numbers at the two corners are the same, and then the two powers must add up to n. So this is n, and this is 1, this is n minus 1, 2, n minus 2, and n, and this is 0. So this is just a very quick overview of the binomial theorem. So if you need more details, you can just refer to the previous video. Now, having written down this binomial theorem, we already know that there's something common among all the terms, which is the NAB part. And what really differs is just the number, this number here. We can write down what we call the general term. We know that all terms are made out of three components, and there's an n, a, and b. Now, instead of using a number here like 0 for this value, we are going to just denote it as r. We just let r represent this number. If this number is r, then we know that diagonally across this power is r. And the two powers, since the power of a and b must add up to n, this one must be n minus r. Really, what is different comparing this general term to what we have previously, let's say to this term, it's just that instead of the number 2, we change all the 2 to r. That's all. Of course, if you compare it to another term, it's the same. The only difference is that we change the 1, we change it, this number 1 here, we change it to r. The general term is also known as the r plus 1 term. And why is that so? Let's look at all the terms that we have here. And look at the first one. Here, my r, which is this value here, is a 0. R is equals to 0. And this is the first term. The first term we can write it explicitly and call it the first term. But normally we use a symbol and just represent it as T1, where 1 of course stands for the first and T stands for term. Now if you look at the second one, here my r is equals to 1. And this is the second term. So this is the second term, T2. You look at the third one. Here my r is a 2. So r is equals to 2. And this is the third term, T3. So if you compare the term number, you see that it's always 1 bigger than r. For instance, like this is T3. And 3 is actually really just 2 plus 1. Therefore, we can just call the general term the r plus 1 term. Right, with this, we are now ready to look at some examples of how we can use the general term to help us solve. In fact, the most common type of questions that we get when they test us the general term is how to use the general term to find a specific term. That means instead of doing the full expansion and finding all the terms, we use a general term to focus and zoom in on the term that we want. There are two types of questions that we can get when it comes to the general term. The first type of question is we will be asked to find a term and r is given. And the second type is when r is not given. So let us look at the two types of questions one by one. The first one, a case where r is given. An example would be a question where, let's say, I have a certain expansion. Maybe I have this x squared minus 1 over 2 x cubed to the power of 7. And I ask you to find the fifth term. For this example here, because we know that we want the fifth term, which means we want t5, and we know that the general term is given as tr plus 1, therefore finding the fifth term is the same as finding t4 plus 1, which means that in this case r is given as 4. So if r is given, it is very easy to find the term that you want because there's no unknown. Therefore, for this question, to find t5, you just use the general term, write out the three brackets, write out your n, a, b, and we know that r is 4. So this is 4, this is 4, and this is 3. Then what is left is simply to simplify these three brackets. Let us just simplify the numbers first, the coefficient first, and that is made out of 7 choose 4 and 1 over 2 to the power of 4. You can punch that into your calculator, and that gives me 2 and 3 over 16. 2 and 3 over 16, normally we present it as an improper fraction. So you'll be 35 over 16. I'm going to write it in red as well. So this is 35 over 16. And then the second part, we say we have to deal with the sign as well, right? So the sign we have here, this is a negative sign. There's a negative sign, and again, because it is inside this bracket, it is also raised to the power of 4. So negative sign raised to a power of 4 is an even power. So it's negative times negative times negative times negative, and that will simplify to positive. And finally, we have to look at the powers of x. And powers of x, that would be from here. This is a power of x, and then it's raised to a power of 3. And we also have this one here, and it's raised to the power of 4. So this is x squared to the power of 3, and I have a 1 over x, 3 to the power of 4. This thing here gives me x to the power of 6. The first one gives me x to the power of 6. And the next one is 1 over x to the power of 12, which simplifies to x to the power of 6 minus 12, which is x to the power of negative 6, which is 1 over x to the power of 6. So my final answer, I can say this is 35 over 16 times 1 over x to the power of 6. That simplifies to 35 over 16 x to the power of 6. So that is the answer for this question. Now let's look at the next one, the case where r is not given. Now r is not given it's of course harder because there is an unknown and you have to figure out what is r. Now when r is not given, typically what happens is that the power of x is given. So let's look at an example. Maybe I have something like x squared minus 3 over x to the power of 5. And I ask you to find the x term. We wouldn't know which term is the x term. It can be the first term, it can be the second term, and so on. But what we know is that the power of x is 1 because x just means x to the power of 1. So therefore, what we have to do is to write down the general term first, and then from there we will study and analyze the power of x in the general term, and we will equate it to 1. Let me write down the general term. Now this, we write it as r, this is r, and this is 5 minus r. Right? So from here, we have to extract the powers of x. Here, 5 choose r, there is no x, so we don't have to bother about that. Your x is found in the second bracket. This is your x, and it is raised to the power of 2, and it is further raised to the power of 5 minus r. And then in the third bracket, you have an x here, and we know that if it is just x, it really means x to the power 1. Therefore, here my x is raised to the power 1, and it is further raised to the power of r. Therefore, if we just extract the power of x, this is actually 2 times 5 minus r. And this one here is actually -1. So that is a plus -1 and then multiply by r. Let me just show you how I get this thing here. So I'm going to write it over here. So here we have x squared to the power of 5 minus r, and then we have 1 over x to the power 1 to the power of r. Here we are only looking at x. We are not interested in the numbers like 5 choose r here, and we're also not interested in this -3. Okay? We only want to look at x. Let's see how we can simplify these powers of x here. I'm going to do it factor by factor. So the first factor, we have x to the power of 2, and that's further raised to the power of 5 minus r. From our laws of indices, we know that if we have x to the power of m to the power of n, this becomes x to the power of m times n. And that's what we're going to do here. So that gives me x to the power of 2 times 5 minus r. Now, let's look at the second factor, which is this one here. Now, this one, we need to do a bit more work because the x is in the denominator. And we learned that if we have 1 over, let's say, x to the power of n, it becomes x to the power of -n. So that gives me x to the power of -1 to the power of r. So this is for the second factor. And I need to further simplify it. So the next one, this one stays as x to the power of 2, 5 minus r. And this becomes x to the power of -1 times r. And finally, we can multiply the two factors together. If I have x to the power of a times x to the power of b, this one becomes x to the power of a plus b. So therefore, to multiply the two factors that I have, I add the powers. So that is x to the power of 2, 5 minus r, plus -1 times r. Right? So that is how I got what I have here. Okay, now let's continue on with the previous question. For this question here, we are asked to find the x to the power 1 term. So I will say the power of x is 1, and that is equals to the power that I got from the general term. Now all I have to do is to simplify and find my r. Once I found my r, I can then put the r inside the general term, and I can find the term that I want. So let me erase all this here. Now I can move on to find my x to the power 1 term. The x to the power 1 term is equals to 5. We know that now the r is 3, so it's 5 choose 3. X to the power of 2, and 5 minus r is 2. And then this is -3 over x to the power of 1 and to the power of 3. Again, simplify these. We start with the number. So 5 choose 3, and this is 3 to the power of 3. So that is 270. And next, we need to look at the sign. I'm going to use green for that, or maybe let's use blue. Okay. So this is negative, and it is raised to the power of 3. So negative raised to the power of 3, negative times negative times negative, that is still negative. So I'm going to put the negative sign here. And finally, we're going to simplify the x. Actually, we have already simplified it and we have already set it to 1. So it has to be x to the power 1, but we can verify it. So here we have x squared to the power of 2. That gives me x to the power of 4. And then here we have x to the power 1, but it's in the denominator, to the power of 3. So it's actually x to the power of 4 divided by x to the power of 3. And as expected, that gives me x to the power of 1. So therefore, the answer is just -270x. Let's look at two more examples. The first example, I will give you one that the r is given. I have this question here, 2x cubed minus 1 over 3x squared to the power of 10 and I want you to find the middle term. This one, the r is actually given indirectly because we know that the power is 10, so that means I'm gonna have a total of 11 terms. So your job is to figure out which is the middle term. I'm gonna have the first term, the second term, the third term, and all the way until the 11th term. So which is the one in the middle? These two extremes, let's cancel them off. These two, these two, these. The middle term is T6. So let's do that. We know that T6 is equals to T5 plus 1. That tells me my R is equals to 5. And that is equals to, let's write down the general term, 10 2x cubed negative 1 over 3x squared. And my R is 5, so this is 5, 5, and this is also 5. So simplifying these, so 10 choose 5 times 2 to the power of 5 times 1 over 3 to the power of 5. And that gives me 896 over 27. Then next I'm going to figure out the power. The power here is there's a negative sign and that is raised to the power of 5. So it's an odd number of negative signs. So it's going to be negative. And I'm going to figure out the powers of x. So that is x to the power of 3 to the power of 5. That gives me x to the power of 15. And that is going to be divided by x to the power of 10. So that is x to the power of 5. Right? So this is my middle term. Okay, one more example. I have this expansion, x squared minus 1 over 3 x 4 to the power of 9. And this one I want you to find the term that is independent of x. Here we have a key phrase, the phrase independent of x. Independent of x means that it's a constant term. Because a constant term is independent of x, it doesn't have any x in it. So it is actually indirectly telling you that they want the x to the power of 0 term, which is of course telling you that the power of x is 0. So with that, let us write down our general term. 9 x squared negative 1 over 3 x 4, and this is r, and 9 minus r. Let us extract the powers of x. So I hope you are more or less familiar with extracting the powers of x by now. So power of x is equals to 2 times 9 minus r. That's from the first factor here. Then plus from the second factor, because x is in the denominator, so it's actually a negative 4 and times r. And we say that we want the power of x. The question is asking for the power of x to be 0. So we're going to put 0 here, and that is equals to this 18 minus 2r minus 4r. So therefore, my r is 18 divided by 6r is 3. So with that, I can now find the independent term is equals to 9 choose 3 x squared. 9 minus 3 is 6, and negative 1 over 3 x4 to the power of 3. So simplifying this, 9 choose 3 times 1 over 3 to the power of 3. So that gives me 28 over 9. And then next we look at the sign. I have a negative sign here, and that is raised to the power of 3. So it's an odd number of negative signs. So that is negative. And then we look at the powers of x. I hope you are not surprised that the powers of x should eventually be 0. And we can verify that this is 2 times 6, which is 12. And then this is 4 times 3, but because the 4 is in the denominator, so it's actually x to the power of 12 divided by x to the power of 12, which cancels each other off. So therefore, my independent term is just negative 28 over 9. Okay, so this is just a quick overview of how you can find a specific term using the general term. That completes the second part of our binomial theorem series, which is this one here. And we've done this. So the next videos we'll be looking at um, the remaining types of questions, which is product of expansion, expanding three terms, and finding n. And we also elaborate on and choose R. Okay, thank you.